Banboye, Banboye, Ezule, Banboye, Banboye, Banboye.
You're welcome. This is PCH's compound. You are welcome to the program we have to give for you, which we are going to call it the Essentials of Advanced Level Biology Practical. However, we are going to give so much thanks to God who has given us the inspiration, and we hope that He's going to guide us throughout as we go through the program so that we help you. The aims of these programs are that candidates who are to write the GCE practicals, A-level biology, they will be able to view what they have done in class. They will be able to observe experiments, follow the instructions, and in so doing, they will be able to remember these instructions and put them down when they are writing their exams. So we are going to go now to the environment to see how we can get some facts from the environment, and we'll come to the lab to see how the experiments are carried out. You are welcome. Here is a tree, this is a palm tree, where we are going to see how plants have been succeeding on this tree. So if we consider this palm tree as a virgin plain, then we are going to see that here, when this plant was first growing, there were no mosses. But we have seen that there are tiny mosses that are growing on this bare side of this plant. So this is the back. And you realize that after these small mosses, when they grew, after a season, they will die out. But when they die, their bodies are decomposing and they will add onto a small layer of humus onto it. And the larger mosses will grow onto it. You see that these ones are larger than these ones. And as they grow with time, you realize that they will be adding a layer of humus and eventually the layer becomes thicker. So you now realize that down here, when the layer of soil, of humus now becomes thicker, this layer now becomes sufficient for the smaller herbs to start growing onto this plant. And as they are growing, the environment becomes very uncomfortable or very unsuitable for the mosses. So the mosses are dying out, meaning that they have set the pace, they have made the environment to be suitable for the herbs and less suitable for themselves. And then eventually you realize that the larger plants, the larger herbs, larger than this one, will start coming in. You can see this epiphyte. This one is quite a small one. It has a thin layer of humus and it will come up this way. You see that this one is quite a larger epiphyte which is growing on this plant also because the mosses have grown and deposited a thicker layer of soil inside. So you also realize that as these epiphytes are growing, these are orchids, as they are growing, they are dying and these bodies are decomposing. So some of them will remain onto these stacks that have been cut, and they will add humus. And eventually you realize that you will find tiny organisms that will be living here, like worms, find them because of the humus layer. So in that environment, you also find that these are clasping. This is a stem that is clasping onto the surface of this palm tree. You realize that this is not a parasite because it does not send its root deep into this plant to absorb food, but it just grows on it like that and obtains the nutrients from the surface. So you can see what is happening. So you see that these ones are the rhizoids. These are the rhizoids that trap the nutrients from the thin layer of soil that has been formed by the mosses that have been growing on it. So eventually, if this were a land, let's say a field, an A field or so, which has been abandoned and it was cemented, you realize that with time, the mosses will start to grow on it, and after the mosses will be growing, they will be dying and adding a layer of humus, and eventually the herbs will come in. From the herbs, the shrubs, from the shrubs you have the trees, and as these changes are taking place, other animals also come in until you eventually have a climax community. So it is certain that plant succession in biology, ecological succession, involves a virgin land which changes gradually with time until a climax community is formed there. So if you can extrapolate this to a large field, you see that in subsequent years it will be a very climax forest. This grass, we call it the Comelina, and this grass is very important for biology practicals. We either use this grass or we use what we call the Tradescantia, which is similar to this. So this grass, if candidates know that this grass that is just growing around the school is what is used to give them certificates then they will be very observant with the environment. Because you realize that this grass that I've just cut here, we have preserved it here, it is in certain locations, and we always use it for microscopy. You realize that when we take this grass to the lab, we are going to use it to answer a full question, and this question can award candidates about 30 marks. So if candidates know that their environment is made up of common things, everything that they use for their practicals, and they move around and they are very observant, they look at plants, they try to give them names, even if they cannot give scientific names, to give them common names, just attaching common names and being able to identify those organisms, then it will help them very much. But however, if candidates are able to give scientific names of organisms, both plants and animals, and be able to isolate and say that this is organism A or B, then they have gone a very long way in their practicals. So we are going to go to the lab now and see how we are going to use this particular grass that I'm holding to obtain many marks.